Hello students! It's me, Teacher Raya, your teacher on screen. Welcome to the 5th episode of Scientific Journey, where you can learn science concepts in fun and easy way. So fasten your seatbelt and be ready to explore the wonders of Science 9, only here at Salida La Filipina TV. Are you ready to discover new things? So what are we waiting for? Let's start our adventure by playing 4 Pigs, 1 Word. The game mechanics are very simple. The game has 5 levels. Each level displays 4 pictures linked by 1 word. To make it easier, I will give you hints such as number of letters and keywords or phrase that serve as your guide in guessing the exact word. You only have 5 seconds to write the correct word in any piece of paper. Are you now ready, grade 9 students?
Yeah!
Let's start the game! Number 1. Here are the pictures. It is 5 letters word. It is deep within the earth that consists hot fluid. What is the word? Awesome! The word is magma. Number 2. Here are the pictures. It is 11 letters word. It's a degree of hotness or coldness and measured with the use of thermometer. What's the word? Incredible! The word is temperature. Number 3. Here are the pictures. It is 7-letter words. An opening in the Earth's crust. It allows molten rocks beneath the crust to reach the surface. What is the word? Excellent! The word is volcano. Number 4. Here are the pictures. It is 9 letters word. It refers to the material's resistance to flow and describes as liquid, thickness, and stickiness. What is the word? Great! The word is viscosity. Number 5. Here are the pictures. It is 6 letters word. It is a funnel-shaped opening at the top of the volcano. What is the word? Amazing! The word is crater. Brilliant! I know you got all the items correctly. I'm happy to know that you can still recall important scientific terms which you learned from your previous level. Come on, students! Let us know our lesson objectives. This session will cover our most essential learning competency, that is to explain what happens when volcanoes erupt. Specifically, you will learn the following lesson objectives. First, explain what causes volcanoes to erupt. Second, discuss the nature of volcanic eruption. And lastly, identify factors that affect the viscosity of magma. Before we begin, make sure you have your pen, paper, and self-learning modules with you so you can write all the things that you learned from today's episode. Whether you are in the depths of the volcano or at the highest peak of the mountain, there are many words to explain volcanoes. From your previous lesson, you have learned that volcanoes are vent, hills or mountains from which molten or hot rocks with gaseous material have been ejected. You also learned that volcanoes usually have a summit, slope, and base. At the summit, there is an opening which may be either a crater or a caldera. A crater is a funnel-shaped opening at the top of the volcano, which is connected to the magma chamber by the vent, while a caldera is formed when a part of the wall collapses following an explosive eruption. Let's explore more! Now students, please open your self-learning module to page 6, module 2. Are you ready to begin our quest towards the center of the volcanoes? Alright, let's explore together! Have you ever witnessed a volcanic eruption? What it looks like? Do you know the reason why it erupts? Earthquakes and volcanic activities are common in the Philippines, which lies along the Ring of Fire, a zone of major seismic activity,
where one of the world's most active fault lines are located.
Last January 12, 2020, the Taal volcano in the Philippines awoke from 43 years of being quiet and began to spew gases, ash, and lava into the air. In a few days and weeks, the eruption dropped a layer of unusual wet, heavy ash on the surrounding landscape, weathering vegetation, and turning the lush field and forest of Volcano Island a ghostly gray. Let's discuss what are those factors that cause volcanoes to erupt. Deep within the earth is so hot that some rocks slowly melt and become a thick flowing substance called magma. Since it's lighter than solid around it, magma rises and collects in magma chambers. Eventually, some of the magma pushes through vents and fissures to the earth's surface. Magma that has erupted is called lava. Some volcanic eruptions are explosive and others are not. The primary factors affecting the volcano's eruptive style are the magma's temperature, its chemical composition, and the amount of dissolved gases it contains. To understand more about this, let's watch this video clip. This time, let's describe magma's viscosity. Viscosity is the property of materials' resistance to flow. It is also described as the liquid's thickness and stickiness. The more viscous and thicker the material is, the greater is its resistance to flow. To understand further, let's watch this simple demonstration. Hello students! Today, we will explore all about viscosity. After going through this demonstration, you are expected to explain the process involved when different materials combine through making lava and rate of flow. Here are the materials: flour, water, food coloring, red, blue, and green, 250 ml beakers, textbook or binder, aluminum foil, marker, spoons, stopwatch, plastic ruler, newspaper, baking powder, 350 ml beakers, 3 100 ml Erlenmeyer flask, spatula, and 3 droppers with vinegar.
Preparation making the lava. Procedure number 1. In one of the 250 ml beakers, make lava that is 2/3 felsic mineral that is represented by the flour, and 1/3 mafic mineral that is represented by the water. Combine and stir the mixture until smooth. Color this lava with red food coloring. Procedure number 2. In a second 250 ml beaker, make lava that is 1/2 felsic mineral represented by the floor and 1/2 mafic mineral that is represented by the water. Combine and stir the mixture until smooth. Color this lava with blue food coloring. Procedure number 3. In the third 250 ml beaker, make lava that is 1/3 felsic mineral that is represented by the floor and 2/3 mafic mineral that is represented by the water. Combine and stir the mixture until smooth. Color this lava with green food coloring. So these 3 250 ml beakers are all example of lava. Now let's move on to the rate of flow. Procedure number 1. Set up a ramp at your table using a binder or textbook. Cover your textbook with aluminum foil to keep it from getting dirty. Extend the foil past the book onto the table. Number 2. Near the top of your ramp, mark 3 separate starting lines using the marker. Number 3. Collect a spoonful of each type of lava. Plop one of the lava samples down at the top of the ramp at one of your start lines. Plop one of the lava samples down. Get the other lava and plop it at the top of the ramp. Observe the flow of each lava.
Here are the guide questions. You only have 5 seconds to answer each question. Question number 1. What factors affect the rate of flow of the lava? Letter A. The amount of the floor and the water. Letter B. The amount of food coloring and flour. Letter C. The 250 ml beaker used. Or letter D. The amount of water and food coloring. The correct answer is letter A. The amount of the flour and the water. Question number 2. What happens to the viscosity if the lava flows quickly? Letter A. Higher. B. Lower. C. It doesn't matter. Or letter D. Not enough information. The correct answer is letter B. Lower. Question number 3. In the demonstration, what happens to the rate of flow of the lava if the amount of flour in the mixture is greater than the water? Letter A. Higher. B. Lower. C. Normal. Or letter D. Not enough information. The correct answer is letter A. Higher.
Let's proceed with the 3 factors that affect the viscosity of magma. First, let's look into how temperature of magma affects its viscosity. The viscosity of magma decreases with temperature. The higher the temperature of magma is, the lower is its viscosity. As lava flows, it cools and begins to harden. Its ability to flow decreases and eventually it stops. Second, let's look at how the composition of magma affects its viscosity. Magma with high silica content are more viscous than those with low silica content. The magma that contains less silica is relatively fluid and travels far before solidifying. In this case, if lava flows rarely kill people because they move slowly enough for people to get out of their way. Tephra can range in size from tiny particles of ash to house-sized boulders. Explosive volcanic eruption can blast out cloud of hot tephra from the side or top of the volcano. These fiery clouds race down mountain sides, destroying almost everything in their path. Ash erupted into the sky falls back to the earth like powdery snow. If thick enough, blanket of ash can suffocate plants, animals, and humans. Third factor that affects magma's viscosity is the amount of gases contained in the magma. Gas, mainly water vapor dissolved in magma, tends to increase its ability to flow. Therefore, in near-surface environment, the loss of gases makes magma more viscous, forming a dome or a columnar. According to the Philippine Institute of Volcanology and Seismology, or PHIVOLCS, there are other volcanic hazards that are directly associated in the eruption, such as pyroclastic density, currents, or PDCs, lateral blast, and volcanic gases. Pyroclastic density currents, or PDCs, are mixtures of fragmented volcanic particles or pyroclastic, hot gases, and ash that rush down the volcanic slopes or rapidly outward from the source vent at high speeds. PDCs are the most lethal of all volcanic hazards and can cause incineration, asphyxiation, abrasion, dynamic pressure impact, and burial in hot volcanic material. The lateral blast are laterally directed thrust of hot gas and ash that can be generated from an exploding dome on the summit vent, or inside the edifice when sudden mass failure of volcanic flanks occur. The volcanic gases form a dissolved component of magma that is released to the atmosphere in large quantities during eruptions. The principal volcanic gases are water vapor, hydrogen sulfide, sulfur dioxide, carbon dioxide, carbon monoxide, hydrogen chloride, and hydrogen fluoride. Minor amounts of nitrogen, methane, argon, and helium can also be gassed from magma. To understand more about our topic, let's recall what we have learned today. We have learned that magma rises and collects in magma chamber. We also learned the primary factors affecting the volcano's eruptive style. These are the magma's temperature, its chemical composition, and the amount of dissolved gases. We defined also that viscosity is the property of the material's resistance to flow. And lastly, there are other volcanic hazards that are directly associated in the eruption. These are pyroclastic density currents, lateral blasts, and volcanic gases. Okay, students! I'm sure that you can still remember our discussion earlier. This time, let us answer the following statements with true or false. Now here's the direction. Write check mark if the statement is true and cross mark if the statement is false. Then, I'll give the correct answer. You will be given 5 seconds for each item. Are you now ready, grade 9 students? Let's begin! Number 1. Temperature of magma affects its viscosity. Is it true or false? Correct! The answer is true. Number 2. The lower the temperature of magma is, the lower is its viscosity. Is it true or false? Great! The answer is false. Number 3. Magma with high silica content are more viscous than those with low silica content. Is it true or false? Amazing! The answer is true. Number 4. The magma that contains more silica is relatively fluid and travels far before solidifying. Is it true or false? Brilliant! The answer is false. Number 5. The amount of gases contained in magma affects its viscosity. Is it true or false? Exactly! The answer is true. Good job, students! I know you were able to answer the test correctly. You may read and answer the activity on Let Us Enhance on page 15 and complete the Venn diagram on Let Us Reflect on page 16. Got it? Way to go! Hope that you have learned something new today. Thank you so much for joining, and please make sure to be with us in the next episode only here at Salida La Filipina TV. In collaboration with Epet TV, tara na! Again, this is Teacher Rhea, reminding you all that during volcanic eruption, be alert, expect the unexpected.